friends, today we're going to go over lesson 4 for decimals, and as I mentioned last week, today we are going to start getting into hundredths. So last week we worked with tenths, and now we're going to be working with hundredths. And let's read through the objective first. So the objective is students will be able to use meters to model the decomposition of one whole into hundredths, represent and count hundredths. So before we even get into the actual lesson, let's think back to when we thought of meters. We know that 1 meter is equal to 100 centimeters. So if we're looking at this 1 meter, think of it as having 1 hundredths in here. However, these hundredths could also be broken down into groups of 10, and I'm not sure exactly how those would look like, but they would be about that size. And you can make 10 groups of 10, which would give you 100. And that's important because last week we learned about tenths, which is 0.1 as a decimal, or you could imagine it as 10 cents in money. As a fraction, that was 1/10. But this week, or this lesson specifically, we'll be focusing more on hundredths. And as a decimal, hundredths look like 0.01. And if you're thinking of money, these are more like 1 penny, not 10 cents anymore. And as a fraction, this is 1/100. Now, because I know that this is 1 cent and this is 10 cents, we know that 10 hundredths make 1/10. As we see here, 10 hundredths is the same as 1/10, and the way you would know that is you kind of just cross off the zeros. You would have 1/10. Same with 20/100 is equal to 2/10. Same thing here. If I crossed out the zeros, I would get 2/10. And this pattern would continue. So knowing that, let's look here. Say this is 1 meter. 0 is the same as 0 hundredths. 1 is the same as 10 hundredths. Sorry, 0.1 is the same as 10 hundredths. 0.2 is the same as 20 hundredths. 0.3 is the same as 30 hundredths. 0.4 is the same as 40 hundredths. 0.5 is the same as 50 hundredths, or 1/2. 0.6 is the same as 60 hundredths. 0.7 is the same as 70 hundredths, and you get the point. So if I told you to put 25 hundredths on this line, you knew that 25 hundredths would be past 0.2, because we know there's already 0.2 there. So it's going to be a little more because there's another number there. But it's not quite 0.3. So we knew it would land in between here and here. And because we know what lands right in between would be 0.25, or it would land right there. So if we think of this again as a meter, and we were plotting 25, or we were showing 25 hundredths in this entire model, this model has 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeters. So imagine there's 100 centimeters. Of course, I don't have every little line, but you're imagining that I do. And you have 10 filled in here, as we know, because this is 1 square. And you have 10 filled in here because you know that this is another square. And this is 1, 2, 3, 4, 5. This is 5. So I have filled in 25 out of 100 possible numbers to fill out. Now, as I mentioned before, 1 meter is the same as 10 centimeters, and 1/100th meter, 1/10 meter is the same as 10 centimeters. 1/100th meter is the same as 1 centimeters. Now, how does that make sense? Well, if we colored 1/10, so 1 out of 10 of a meter, this would be 10 centimeters. Because we knew total, there would be 100. But if we colored 1/100th, we would have only colored one little front right here out of the 10 in this whole square. 1 meter is equal to 100 centimeters. And for that reason, 1 centimeter is equal to 1/100 meters, because when you get 1 centimeter, you are only coloring 1 out of the 100 pieces. Likewise, if you had 1 centimeter, it would be 0.1, because you would not have 10 centimeters, you would have 1 centimeter. And 1 out of 100 is written as 0.01. Because remember, 1 over 10 was written as 0.1 or 0.1. 0.1. Notice how this extra 0 matches that extra 0 there. There's no extra 0 here, so there's no extra 0 here before after the decimal period, sorry. So, one thing that's going to get a little bit tricky during the problem set is you're going to have some questions that kind of ask you in a strange way, how do you do something you haven't done before? So it will say, for example, the questions that I think are going to be tricky are questions 3, questions 4, and questions 5. So I think question 3 may be tricky because they're going to give you something that looks like this, and they're going to shade it for you. And the first example has the first one shaded, and this is the example that they give for you. And then it has 3 pieces shaded out of 10. So let's pretend that that's 3 pieces right there. Great. And then we know there's 10. Excuse my lines. I'm looking at it through the camera. So let's say that this is what we are given, and you know that there's 10 colored here, and there are 3 colored here, okay? Well, you know all together, this is equal to 100 centimeters. So I know here, I have 10 out of 100 colored, and here I have 3 out of 100 colored. This can be made more simple by crossing out these 2 zeros. So here I actually have 1/10 centimeter that came from here. I'm crossing out the zeros, plus 3/100 centimeter. Notice how this one stayed 100 because I didn't have any 0 to cross off the top from the 3, is equal to 13 centimeters. Sorry, 13 over 100 meters. Because you could have left that as 10 over 100. That's okay if you do. 13 over 100 meters, which is the same as, if you have 13 over 100, the way you would write that into a decimal would be 0.13. Now, how does that make sense? Or you can do 0.13. The 0 there does not really make a difference. How does this make sense? How did we get 0.13? Well, if we go back over here, remember this is the 10ths place, and we had 1/10. So check. And this is the 100ths place, and we had 300ths. So check. So if I have a model that gives me a full 10 and a partial by giving me 3, so 13 altogether, that would be 0.13. Now moving on to question 4, when you have to do question 4. And this will be question 11 for you. It'll just be question 4 on the problem set. When you get to question 4, all you're going to have to do is they'll give you a fraction and you have to color it in. So when you color it in, remember that this big chunk, the ones that kind of look like this whole piece, think of them as 10 pieces because they are 10 pieces in 100 pieces. And this one you think out of 100 pieces. So there are 100 of these little ones and there are 10 of these big ones, which means that 10 of these little ones fit inside one of these 10s. It's the same thing as when you think of a place value chart. Remember, there's 1s, there's 10s, there's 100s, would look like this, but there's also 10ths, which is what we learned last week, and the 100s are right behind at 100ths. So that is why it makes sense that it takes 10 of these to make one of these. 10 hundredths is equal to 1/10. When they ask you to do a number bond, you're going to do something pretty similar. all you're going to do there is you're going to show me how you break down a number like this by doing it into the tens and the ones. And here the tens would be 20 over 100, which we know we can simplify into 2 over 10. So you just leave it at 2 over 10. And what was left if we took the 20 was 8. 8 over 100, and we don't have a 0 here to simplify, so this is all we would leave it as. Now let's do 62 over 100. There are 6 in the tens place. This would be 60 over 100. I can cross away, which is the same as 6/10, and I have a 2 in the ones place, 2 over 100. Again, notice how there's no 0. I can't cross any of these away. This is not equal to 2/10, this is equal to 2/100. So now my number bond is correct because I have 6/10 and 2/100. So that should be it. I know some of this is a little confusing, but all you really have to remember is that when you think of 1 meter, there are 100 pieces. And if you have 10 pieces in 1 meter, that one piece would equal to 10 centimeters. But if you had 100 pieces, that each piece is equal to just 1 centimeter. That's why 10 over 100 is equal to 1/10, and 20 over 100 is equal to 2/10. If you have questions, make sure you come to office hours. I will go over the lesson a little bit before we get into questions.